Hello dear student, welcome to my channel. I hope you are all will be fine. I'm also fine, thank you. Let's start today topic is about difference between bond energy, bond dissociation energy and average bond energy. What is meant by bond energy or average bond energy or dissociation energy? So let's start today topic. Here is one point same. Bond energy, average bond energy is sometime called, is not sometime, average bond energy is also called, or average bond energy is often simply called bond energy. So it means these two things are same. So what is the difference between bond energy or average bond energy in bond dissociation energy? So what is the difference between bond energy and bond dissociation energy? So let's start today topic. Let's start. So first define bond energy. What is meant by bond dissociation energy? To understanding bond energy, it is necessary that you should need to understand. You should know about what is bond dissociation energy. So let's start. What is bond dissociation energy? What is bond dissociation energy? Bond dissociation energy is the energy. Sorry. Bond dissociation energy is the energy required to break a particular bond to give free radical is called bond dissociation energy. It is very simple. Bond dissociation energy is the energy required to break a particular bond to give free radical is called bond dissociation energy. For example, let's suppose this is H2O, HOH bond. There is partial positive charge, here is partial negative charge because oxygen is most electronegative. So if you give heat to the system, if you break the bond between hydroxyl ion and proton, then what will be happen? It will be like that. If they are, if the bond are homolytically fusion, so free radical will be formed. HO free radical plus H free radical, it will be formed. So after the reaction, it also lose it's also it also this energy will be the breaking need the energy amount of 118 kilocalorie per mole, 118 kilocalorie per mole. This is the energy that required to dissociate or to break the bond between OH and H. This bond breaking is called the energy that break this bond is called bond dissociation energy, and it is known by, and it is represented by capital D. Bond dissociation energy is represented by capital D. This is bond dissociation energy. Is that clear? If you understand perfectly the bond dissociation energy, then it will be very easy for you that what is average bond energy and what is bond energy. Average bond energy and bond energy is same thing. Average bond energy is oftenly called bond energy. Okay, so you can also take screenshot or you can rewind the video. Now I am cleaning the board because of lack of space. So the another thing is average bond energy. What is average bond energy? Average bond energy is often simply called, it is also called bond energy. Bond energy, and is represented by capital E. Capital E. It is average bond energy or bond energy. In polyatomic molecule, let to explain, let to understand the average, what is the bond energy or what is the average bond energy. So if uh, in polyatomic molecule, in polyatomic molecule, there is different bond dissociation energy, there is different bond dissociation energy. For example, in case of ch4, in case of ch4 in case of ch4, this hydrogen carbon bond will be this hydrogen bond, the bond decision energy for this hydrogen and carbon for this bond will be different from this bond, from the decision energy of this bond, and this the decision energy of this bond will be different from the decision energy of this bond, so it will be different. The What is the reason behind this? There is different factor that are involved in the having different bond decision energy. The factors are resonance, hyperconjugation, hybridization, angle strength, steric effect, etc. These are involved in this phenomena, so that's why the bond energy of all the bonded are different from each other. But experimentally, in case of ch4, when the bond is ch3h, if you broke the bond, this will require 102 kilocalorie per mole. The bond decision energy will be like 102 kilocalorie per mole. In case of ch2h, the when you break this bond, when there is only three hydrogen with carbon, so in this case the bond decision energy will be equal to 108 kilocalorie per mole. While in case of chh, in this case bond decision energy will be equal will 10 sorry, not in in this case, when there is three hydrogen, when you remove the one hydrogen from the ch3, it will be required 105 kilocalorie per mole. When there is only two hydrogen and you need to break the one bond of this hydrogen, so it required 18 kilocalorie per mole. While in case of ch bond, when there is no hydrogen, when you dissociate this bond, when you break this bond, this will require the bond decision energy for this bond is 83 kilocalorie per mole. 83 kilocalorie per mole. As that clear? For the to take average of this, the average of this is 9. You can also take the average like that. You can also take the average like that: 1 divided by 4 multiplied by 102 plus 105 plus 108 plus 83, it will be equal to 99.5 kilocalorie per mole. kilocalorie per mole. So this energy is called bond energy, or you can say that bond energy, or you can say that that is the average bond energy. This energy is called bond energy. Bond energy may be measured from the heat of atomization. It may be measured from the heat of atomization, but the more usual practice to calculate it from the heat of combustion. Mostly it is from heat of combustion. More usual practice to calculate to calculate average bond energy or bond energy from the heat of combustion. Is it clear? uh, Bond energy is measure of bond strength. It also the different bond, we can say that this bond is strong bond and this bond is weak bond. It is due to we can measure, we can give strength to the uh, different bonds from the bond energy. Yeah, shorter bond will have stronger bonds. Shorter bonds are stronger bonds because a dissociation energy will be high. Let's suppose this is shorter bond, while this is longer bond, while this is much longer bond from this one. So this will require more energy, this will require less energy, this will require very less energy, so the bond dissociation energy will be decreased. So these all are the points. In case of bond dissociation energy, the energy that is required to break the bond is called bond dissociation energy. Similarly, in the formation of that bond, when once the bond is broken, after the formation of that bond, the same amount of energy will be released, like when the energy was given to the bond was. Okay, is that clear? So these are the something about some difference about a bond energy and bond decision energy. I hope you are will be clear. Thank you. If you like my teaching method, please support me, help me, and subscribe my channel. It make me feel happy that my students are supporting me. Okay, thank you. Best of luck, my dear student. Best of luck, my dear student. You can also rewind the video, or you can also take screenshots. Okay, bye. Best of luck.